All right, here's 2-1, day 2. Get this labeled for you. We're still working with quadratics, kind of a variety of little things that we're doing with them. Most of them algebra-based, not a ton of graphing. We've talked about graphs and whatnot, but well, we'll kind of lump that in with higher ordered polynomials and get real serious about graphing. I think it's in, I want to say section 3, maybe. We kind of get into the graphing side, but stuff today is still more algebra-based, okay? What I want to do is write the equation of a quadratic, and really what that means is I want to find A. Now I'm going to get myself set up with vertex form, because this problem tells me the vertex. That's kind of my red flag here that, hey, this would be the way to set it up. Because really, if I'm trying to write the equation of a quadratic, I need to find A, which is a really significant number for any quadratic because it determines if it opens up, down, and how wide it is. It tells us a lot about that particular quadratic. The only thing is I need one other point, which here I have, okay? So if I were to go through and kind of label all this stuff, 1 and 2, that's my vertex. That's H and K. And for this point, that's X and Y. So Y is 0, A is unknown, X is 0, H is 1, K is 2. And notice with the vertex and one additional point that's on this quadratic, I'm good to go. Good to go in the sense I can solve for A. Negative 1 squared is just 1. Subtracting 2 from both sides, I get that. Okay. A is negative 2. Final answer would be that Y, right? I'm not going to keep the point 0, 0 in there anymore, but I will substitute in that A is negative 2, X minus 1 squared plus 2, and that quadratic would model the data that I was given, okay? So pay close attention if you're asked to do that. If you're given the vertex, vertex form is the way to start, and keep in mind you're really just looking for A. It's what it's all about. I want to give you a little alternative method to find the vertex, right? We've talked about vertex form, which is great, right? You just observe it and say, hey, H is 1, K is 2, the vertex is at 1, 2. Now, if you were to take this equation right here and FOIL it, okay, which would basically mean expand it to standard form, you would see f of x is negative 2x squared plus 4x. So A is negative 2, B is 4. Okay? If I wanted the vertex, I could still get it, right? Let's pretend that I didn't have, this vertex form, which if you had wanted to go from standard to vertex, right, I think this method is a little less work and more efficient. You could do that. It's called completing the square if you're going to switch from standard form over to vertex. So you got that in day 1. You could go that route. The other option, that's, again, why I'm calling it an alternative, would be to use negative b over 2a, and then, of course, plug that value in to your quadratic to get the y value, okay? Kind of running out of room here. So x would be negative 4 over 2a, which is negative 2, which is 1, okay? And again, this is the same quadratic, so not a shock that it's 1. And now to get its y value, That's what the second part right here is saying, right? Because we just did this part to get the x. Here's the y. I plug it back in. And I get 2. And there you would get your vertex at 1, 2. So negative b over 2a, again, that's this piece right here. If you had a quadratic in standard form and you want to quickly get the vertex, great way to do it. All right, an alternative method to finding x-intercepts. Okay, and by alternative, I mean not factoring, which we covered in the first day. This one I don't think is going to be super surprising. I'm sure you've seen it many times. If you're looking for x-intercepts, or what we call zeros, and factoring isn't working, use a quadratic formula. Okay, all you have to know is a, b, and c. It works perfectly if you're in standard form. Okay. So this is another one that I picked the same equation that we used yesterday, which we factored. And I want to say we found that its zeros were 6 and like 2.5, or maybe negative 2.5. So we should be able to compare the answers we get here. So this one's a little bit different. That, yeah, I could factor it. Let's say I didn't want to, or let's say I didn't realize that it was. That's when you go to this alternate method of the quadratic formula. First thing is to just make sure everything gets plugged in where it belongs. All right, everything's in. This part's usually worth a double check to just see any mistakes and where I put stuff, because if there is, I'm not going to get my zeros, right? I'm kind of doomed from the beginning if I have a number in the wrong spot. All right, so go 7 plus or minus whatever that square root simplifies, 2 over 4. That's where you spend most of your time number crunching, but you should find that that's all 289, which the square root of 289 is 17. So this will give us 2 solutions, right? The first would be 7 plus 17 over 4, which would be 6. This would be negative 10 over 4, or negative 2.5. Okay? Now, just kind of a side note for a little observation with this. This part right here, right? You could pick up on some patterns. For b squared minus 4ac. Okay? If you notice that equals 0, you are going to have one solution for your x-intercepts. And that's a possibility. We didn't see it here, but that, that number theoretically could simplify to 0. Probably the most common case that you'll come across is that it's greater than 0, like here. There we had 2 solutions. And you could get a negative number, which would mean if we're talking just about real numbers, we're not going to get into the complex number game yet. But that would give you 0 solutions, which again, we did not see that here at this point. But if you did get a negative underneath that square root, that's what's going on. Okay, but those are the 3 possibilities, which is why a quadratic, when you're looking for its x-intercepts, you can get 0, 1, or 2, right? You can't get 3, because a quadratic can only change direction 1 time, so no more than 2. All right, a couple applications, and for the most part, like applications with quadratics in terms of the math that's involved, they're not crazy, okay? You're probably going to be going one of 2 routes. Either you're looking for x-intercepts or the vertex, right? And that tends to be the biggest piece, is to like read the problem carefully and look for, all right, which is it that we're doing, okay? Anytime I see this, maximum, right, maximum height, that tells me this problem is about the vertex, okay? Now you can see the vertex is labeled, and there's the coordinates. So really, in terms of your notes, all I'm going to fill in here is, all right, they're looking for the maximum height of the baseball. How do we get that number, right? I'm kind of filling, there's the answer, but I'm going to fill in the work, right? Now, the first thing I would notice here is if I'm thinking X and Y, the distance the ball traveled is like an X. The height is like my Y, okay? So the big thing here that I realize is this problem, because it asks for height, is about the Y value, which really means 81.125. That's the answer that I should get to, okay? Now it's in standard form, so I'm gonna go to negative b over 2a. B is 1, so negative b is negative 1. 2 times a, which is negative 0.0032. Plug that into a calculator, you'll get 156.25, all right? My concern on this problem is you're like, oh, it's a vertex, negative b over 2a, right? Boom, done. Not quite. This is where, again, the math involved isn't crazy complicated because it's a pretty simple formula. You got to read the problem carefully and recognize, okay, yeah, it's about vertex, but specifically it's about the y coordinate of the vertex, which means we got to head over here. We have f of 156.25 because that's the distance at the max height. Have to drop down to the line below here. Plus 156.25 plus 3. That is where you would get 81.125, and that is in feet, okay? Be careful with that you recognize in that word problem. Again, what exactly is this problem having me do? All right, first part is the vertex, and that second part, okay, once I do negative b over 2a, I got to plug that number back in to get my height of a little over 81 feet. Now this one is also based on vertex. It's about minimum, right? If I see max or minimum, I see vertex. I didn't work one in here. Your homework will. If you got an app, I mean, for the most part, the only other part of a quadratic, an application problem would ask you to do is find zeros. That's the other big thing. Factoring or quadratic formula. Again, I didn't throw one in here, but that's fine. If you recognize that it's not asking you to find the vertex, it very likely is about finding zeros. All right, so I'm finding a minimum. Now, I'm kind of doing the same thing to start. And I'm like, okay. The units produced is like the X, and the cost is like the Y. I think those are really, really good to identify because this is about how many units should be produced. That tells me this is about the X coordinate. Okay, a minimum is going to be a vertex, and this is an X, and we have kind of a funny order here. C is out front, then B, and then A. Opposite of B would be 120. 2 times 0.075. Okay, negative b over 2a. Simplify that, and you would get 800 units, right? Now, I know this is also a vertex question, but the reason I put it in here is it does differ from the last one, is I would recognize, hey, this problem is asking me about the number of units to produce. I've got it, okay? If I were to plug it back in, which I'm not going to, right? Because the problem didn't ask, it would have had to have asked, and what cost would that be? Okay, if you were to go back and plug in 800, you'd get $454,000. That's what the daily cost would be. But again, I'm being particular here. I'm not going to write that out because the whole point of these last two problems is to recognize what you're being asked to find. This one is just the x-coordinate, so I'm free to stop at 800 and say, hey, I've got my solution, okay? Again, in these application questions, which you'll homework, checkpoints, tests, you'll keep seeing them on quadratics. Whether it's factoring, quadratic formula, or finding the vertex, the algebra involved with quadratics is not necessarily crazy hard, okay? What you have to really be particular about is reading the question and making sure you are super, super clear on what aspect of a quadratic it's asking you to find, right? Usually that's where students struggle, is they're like, I don't know what this one's asking me to do, okay? And again, it's not a real long list of stuff. Probably zeros or vertex is what the problem's about, all right? That's all for 2-1, day 2, and that wraps up our 2 days on quadratics.